Ladies and gentlemen, welcome to our last lecture for Organic Chemistry 1 this semester. Monday is review day all day, and I strongly suggest you find some final exam review materials at Moodle because there's some very specific items in there that will help you, so I don't have to answer the question, how many questions are on the test? How is the test laid out? It is all laid out very in detail at Moodle. It's very different than the other tests. You'll find out. But let's finish the semester first. So here we go. Chapter 11, we're not going to do very much of it, just what I think is the essential parts to get you into Chem 242 with sound skills. We do have to name things. A student already named this first one for me. He just threw it out there. He said dipropyl ether. That is one of the names. And that is the common system. Common system in green. And there's another system, the UPAC system. You know all about that. UPAC, International Union of Pure and Applied Chemists. They say the longest chain is 3 carbons. It's propane. And there's a group attached to the first carbon. I haven't lost anybody yet. The group that's not in the circle is not a propyl group because it's attached by way of an oxygen, isn't it? It's a propoxy group. That's new. You just learned how to name thousands of new R groups in one instant. This is a propoxy group. Well, I better keep it blue. I see a propoxy in the next one too. Maybe I should have gone for some variety. Let's go for some variety. I'm gonna change the next one so it's not a propyl on one side. I just made it longer. So please add this new carbon here. What are the carbon groups named on each side? They're different this time, so you can't say dipropyl, but it's the same idea. Name the one on the left because it starts with a B, right? The one on the left is a butyl. Butyl. And the one on the right, 1, 3, 5, 6, hexyl. Separate word. It's 3 words. And it's got to be the easiest system of nomenclature ever, isn't it? You name the 2 R groups and tell me they're attached to oxygen. What word says they're attached to oxygen? Ether. There you go. Now the longest chain here is hexane. UPAC says it's a hexane with a butoxy group on carbon 1. So the new thing is the oxy groups. The old thing's what's in front of them. You change ill to oxy, and you got a whole bunch of new groups. Now this one's got a long chain that you should number from here. It's decane. You could come up with a green system, but I'm going to do the blue one first. It's a decane. And on 5, there's a group. What's the name of the group? They don't keep any of the Y or the L. So isobutyl was its former name before oxygen was snuck in there. So you lose the Y and the L and replace it with what? Get used to the system. Oxy. Isobutoxy. Isobutyl is no more. Isobutyl, YL, became isobutoxy. And it's got a stereocenter that's R. Yeah. I could have made the next one have a couple stereocenters. Oh, let's do the green. Isobutyl is one group. What's the other group called? Are you surprised it's called a 5-decyl? No, it's a decyl attached by way of carbon 5. And I'm just going to make sure these are separate from the next part of the activity. Nomenclature on the final exam, only one area of the exam is multiple choice. You're either given a picture and asked for an appropriate name from the list of answers, or you're given a name and asked for which picture matches that. So yes, there's ways of having you force you to use either system in there, isn't there? Okay. So this one, it's a special ether. This is a triangle, isn't it? Triangular ethers are the most important thing in chapter 11. I'm going to even write that down. The most important thing in chapter 11. They are called, it's a special kind of ether. Let's go with my favorite right here. EPOXIDES. And they are all derivatives of oxyrane. Oxyrane, right here. Oxyrane. That's the parent. Now, something about oxyrane. It's a ring with an atom other than carbon in it. There's a name for molecules like that. It's a field, actually. What's the name for rings that have an atom other than carbon in the ring? Well, those are examples of the broad category of what I just asked for. The broad category includes, so you're saying purines and pyrimidines. You're getting into some biochemical versions of these, but I'm asking for the big category. Any ring, any atom other than carbon in it is called, and this name will make sense, heterocycles. Have rings with atoms other than carbon in one of the corners, one or more. I love when it does that. One or more of the corners. And the most important thing about heterocycles is the heteroatom is number 1. We have never done anything like that before. We've only numbered carbons, correct? You've never put a number on any other atom. You didn't have permission. Well, you have to now. 1, 2, 3. Okay. So if you want to name our molecule after oxyrane, you're going to have to tell me what's on position 2 and what's on position 3. So what's on, well, which one's a better 2, which one's a better 3 down here, based on your knowledge of nomenclature? Left is 2 because it's got 2 groups on it. Right is 3. This is a common naming system using oxyrane. It's going in green. Oxyrane. And it has methyls on 2 and 3 and an ethyl on 2. 2-ethyl 2, 3, that's a comma, dimethyl oxyring. And before I discuss the blue name, which would be the UPAC name, I'm going to introduce to you activity 2, just a preview. Because you'll see my molecule there. We learned how to make that molecule in activity 2. So I'm just going to do a little heads up. And there it is. You're making that molecule. See it? What did you make it from both times? You don't have to write this down. An alkene with the name of, I'd have to call that E3-methyl. Oh, this should be in blue. We're keeping with our UPAC blue today. This is not a waste of time for me to write this here. And that's 2-pentene. Did I do a good job? All right. So that is becoming the molecule we named previously right here. Right here. Got it? And in this area, Dearborn, or in an area like Scotland, where's he going with this? You're used to having names based on where you came from, right? Like, I don't know. Bin, right? Bin, B-I-N? Son of? No? Just throwing it out there. Yeah, okay, good. Or if you're Scottish, what do you do? McDonald, yeah. Son of Donald. So that's the naming for the molecule on the screen here. It came from this, sort of son of this, right? You're going to use that in its name. I'm going to copy paste it. Well, if it lets me. And this computer has a habit of not letting me, so this is very dangerous here. No, I'm not going to do it. Move it out of the way so I can copy the name. Fix it later when I come back. That's how we roll. So we agree that that was the name of the alkene. And here is the finish. Watch. I know it's kind of on top of things. Add the word oxide to indicate it's in what family now? It's the biggest thing on the screen, everybody. It's an epoxide. Okay? So epoxides and with oxide if you're using the system. And the name says there's an alkene in it, but you know better, right? Do you see an alkene in there? Why is there an alkene in its name? Ene. Explain this name or else we can't understand the system. It came from the alkene between carbons 2 and 3, right? That's what the 2-ene means. Where's the epoxide? Between carbons 2 and 3. You're using this system. If this one gets the full numbering treatment, you want to see the 5 carbons? Here they are, 1, 2, 3, 4, 5. This is not the same system as oxyrane. I don't want you to be confused. UPAC's always trying to find the longest chain, right? So 1, 2, 3, 4, 5 with the alkene that used to be between 2 and 3, now having the epoxide. That's how it works. It's not terrible. No. And where are we going after that? Well, apparently we're going up here. Ah, geez, isopropyl methyl ether. You scribble an oxygen on the screen, and you scribble an isopropyl and a methyl, and you're done. Come on, it doesn't get better than that. That's it. Bang. Next one, I'm going to draw an 11 carbon chain. 2, 4, 6, 8, 10, 11. Carbon 5. 1, 2, 3, 4, 5. Has a stereo center with an H on it. And how do you draw a pentoxy, everybody? What do you draw first? Oh, like you said. And then just a pentyl. And make that stereo center R. I think H has to be on a wedge. And O on a dash, and end of song. Oh, what's up with this next one? It's got oxide at the end. What are you going to draw first? You can draw that. We're down here now, right? What two carbons are already accounted for with that name? What two carbons did I just draw? Give me some numbers, please. Two numbers. No, the double bond was not between 2 and 3 in this molecule. It was between 3 and 4. And you have to get up to 9. 5, 6, 7, 8, 9. You got to get back to 1. 2, 1. What else goes on carbon 4? And I do want you to be able to draw this group. Benzyl, how do you draw it? Don't you be drawing any short forms. Okay, well, I'm going to do what she said, but I think she wanted to say something ahead of that. She said hexane, cyclohexane, with double bonds alternating, but don't attach that to carbon 4. That would be a phenyl group. Phenyl group is to benzyl as vinyl is to allele. They are the exact same analogy. Okay? The allele has an extra CH2 in the beginning compared to a vinyl. The benzyl has an extra CH2 in the beginning compared to a phenyl. It goes CH2, then carbon 4. Benzyl. And on every test in 242, in the retrosynthesis, you're going to be starting with benzyl alcohol. So if you don't know what that is, you're skipping a 20-point question every time. Whoa. Let's not do that. So we got to know benzyl. Now you got to work on your stereocenterness. There's an H on stereocenter 3. When there's an H on a stereocenter, I have to see it. The 3 needs to be R, and currently it is R. How do I know that? 1 for a direct attachment to O. 2 for a carbon that has a direct attachment to O. 3 for a C, and 4 for an H. And right now it's R as long as I finish the job. Wedge and some other, dash and some other bond adjacent is a wedge. There, that's an H. Starting over again for stereocenter number 4. Yeah, we'll do it in, I'm sorry I shouldn't have used red twice. Let's retrofit the red to purple. Oops, not that one. Oh, don't be like my other computer. Dead spot. Now it's just teasing me. It's going to tease me on the last day. It's been teasing me every day. I can't get a 2 there. It's going to kill me. All right. Now moving on to the hot pink stereocenter. 1 again. 2 for a C with an O. 3 for a C that goes to a phenyl. 4 for a C that does not go to such phenyl. That's S. I better put the 4 on a. Oh, yeah, you're right. Sorry. 4 on a wedge because it's wrong. Yeah. That's our fix all semester. You'd think I'd remember. And then adjacent for a dash. The 2 took a beating. Okay. And that's it. That's a 3-pointer. Yeah. It's a carbon that's bonded to oxygen. Don't forget, you're talking about the attachment to the thing that's red 3. What are the 4 things attached to red 3? Let me describe them. 1 is a direct attachment to oxygen. 2 is a carbon that has a direct attachment to oxygen. Well, every time you're comparing groups, you have to ask yourself, what's the heaviest thing on that group? So what's the heaviest thing on the oxygen? Well, forget about that story. It's oxygen's heavier than anything here. So I don't have to go further. Oxygen beats carbon. That's an easy story, right? Now, what's the heaviest thing on this carbon? An oxygen. What's the heaviest thing on this carbon? Carbon. We have a winner and a loser. And then we have another molecule. No, we don't. Oh, this crazy guy is out of the, he's just in the whack zone over there. We go, it's actually not a hard one to do. When you see oxyrane in the name, what do you draw first? Triangle with what in one of the corners? O. What atom is number 1? What atom is number 1? The O. 2 has an ethyl. And 3 has an isooctyl. 1, 2, 3, 4, 5, 6, 7. Where's the 8th one? I got a heptyl right now. The V at the end, yeah. And it says trans. I mean, this is up to you now. One's got to be a wedge, one's got to be a dash. That's it. You want to make the left one a wedge, right one a dash, end of story. You could have drawn it's an enantiomer and got full credit, right? Mm-hmm. No, it's not an isooctoxy, which would be cool because it has so many oxygens, O's in the name. We had a gentleman who was getting into the new oxy groups, but this one has none of those. That's our normal old isooctyl group. And it's attached to oxyrane. So there you have it, everybody. Good job. Bless you.